So Bayer is a big international life science company, and we have a history of more than 150 years of research and development. Big and small companies need each other, and we need academia and we need society to find the innovative solutions that can improve life. And tonight we bring different perspectives together. We have a diverse panel, very qualified from different parts, and we will discuss innovation and health. What are the challenges and the opportunities?
Should we welcome the panelists up to the stage and give them a round of applause? So, if you could start and introduce yourselves briefly, what you do, and why you found it interesting to be here, to come here tonight.
Thank you, Alex. It's super nice to be here. My name is Maria Ranka. I'm heading the Chamber of Commerce, which is a business organization here in Stockholm, the capital region of Sweden. And that is a fun job because this is Europe's fastest growing capital, among other things. And I think we are really well positioned to become a global tech hub or health tech hub. We are already a global tech hub, but that is what brought me here.
Very good. Hello, thank you again for inviting me. My name is Jesus Del Valle. I am based in Berlin, Germany, and I run the Bayer Grants for Apps program. What we do is we look for opportunities of collaboration between Bayer and digital health startups. We are right now in 30 countries, and Sweden is one of the latest places where we are just starting to do things. And thank you again for having invited me.
Thank you for having you here.
Hello everybody, my name is Titi Lundgren and I am the CMO, so I work with marketing and sales development within Koala Life, a very exciting company, and what we are actually doing is connecting the heart to the cloud and finding heart disease early and enabling early treatment. So it's also about democratizing the data and to help to win the battle against the leading cause of death in the world, actually. So very happy to be here and talk about innovation.
Great, great.
Great, and my name is Fredrik Lanner. I'm a group leader at Karolinska Institute, and my research group, we work with stem cells and gene technologies, both to try and understand how the human embryo is shaped, how the first week of human embryo development works. We think that information can be helpful for understanding causes of infertility. But we also work with embryonic stem cells that are isolated from this early stage of human development and mature them to mature cell types that we think could be useful in cell therapy to treat diabetes, certain type of blindness, and we're combining gene technology with stem cells to sort of try and address this.
Today, when you talk to startups in this sector, they are facing some challenges when it comes to working with the healthcare providers, which are primarily Landstinget, the county council in this country. So they have to focus much more on innovation and actually letting small new kids on the block in. So, and we have seen that in you know, if you compare it with the ecosystem that has emerged, that is fantastic in this city when it comes to tech. One challenge, and it has improved, but there are still room for even more improvement, has been a sort of lack of collaboration between big companies and startups. Mm-hmm. So that is also important. So there are a lot of things that we can do, but taking success in health tech for granted will not help us.
I am a physicist. I love data. And yeah, you know, I cannot avoid it. So we track everything. And we always look for how many of the startups had a medical doctor, a physician, in their founding team. And at the beginning, it was 5%. And now imagine the medical doctors, these are the guys that at the end of the day, they know probably, they are the most knowledgeable in the whole healthcare system. 5% of the startups, 95% were just some people just working. That's fine, but you need an expert. So over the years, this number came growing higher. Right now, in this year, we had in our application process 1,082 applications, and there were 29% of the startups had a medical doctor as a co-founder, or in the, let us say, in the core team. And that's fascinating. It means they are growing up, they are being mature, and we start now we are starting working with them.
We're probably quite far from the actual commercialization. We're trying to generate ideas of hopefully could be coming to patients, and to come to patients they need to be commercialized. I think that's quite clear. The biggest struggles that we have right now in sort of taking preclinical work, where we say try to treat the specific type of blindness in a rabbit and now go and do it in a human, is regulatory issues, and the fact that laws regulating clinical trials and medicinal products are mainly geared up for pills and pharmaceuticals and not for cellular products. We've made a lot of progress, but we still feel that we fall between different laws often, and this is quite challenging in Sweden and other places around the world as well.
I think there are a lot of regulatory issues right now. Looking at the implementation of GDPR, for example, if we get that wrong, or if we do that in a too rigid way in this country, I think that could be, a destroyer of things that are going on. On the same time, we had a super asset because we have some of the best quality databases when it comes to healthcare in the world, and we're not using it. There are so much leverage from actually starting using the data that is already there. And that could help sort of improve health ultimately, but also it could make healthcare more cost efficient. So there are a lot of benefits if we start to use data, but if we implement GDPR in a too rigid way, that might actually hurt a lot of things that is going on. And I know that the new vice chancellor of KI is very worried about that, and there is a public investigation going on also about the use of data in research. So that, I think that is really a big field.
When it comes to these hubs, or there's a lot of wanting to share. There's a will of making people participate, and I think that's the most important, is that you actually, you're not only looking at your own things, but you're actually saying, hey, have you seen this? You should be in there. And you invite people in. And I mean, that's what it's all about. It's about that dynamic, the sharing, the want of actually wanting other people to succeed. And seeing the advantage of going forward as a group within a specific area. And that's exciting. It gives lots of energy to people. So, yeah, fantastic.
The ability to read our DNA and find mutations and associations between disease and our actual DNA, that sort of emerged in the last 10 years or so. And the big change now is that we've been able to then say, okay, you have a higher risk for this disease or that disease, and we haven't been able to do much about it. But now with the new genome editing technology with CRISPR, we're now actually in the phase where we may be able to then correct that mutation or change that mutation, so you could prevent or treat a disease. And I think from my perspective, that's a huge changer.
Okay, so unfortunately or fortunately, we are humans. Unfortunately, humans have a characteristic common to all of us, namely we are lazy. We don't want to to certain things. We all know if we would eat right things, don't drink beer, go sleep 8 hours a day, and don't eat McDonald's, and make some sport, we all of us would be very healthy. But we don't do this. Therefore, many of us, unfortunately, get sick and so on. It will never happen, in my humble opinion, because we are humans. We are hardwired for party, not for doing things that other people ask us to do. That's my opinion. Therefore, in my personal opinion, what I think that the only thing that would work is technologies and things whereby they are so less invasive as possible. You have a toilet, you sit on the toilet because every day there is no walk around. Every day you walk out and you walk up and you go to the toilet, right? It's the first thing that you do, even before the coffee. Yeah? And then you sit on the toilet and the toilet knows, okay, something is going on there. Yeah? So your doctor your doctor knows this. You become an email automatically, take that pill. That's it. And the pill comes in whatever the form. Every one of us goes to the pharmacy or to Rebe, how do you call this? To the supermarket, at least once a week, right? In the supermarket, you will take your pill. That's it. It will be waiting for you there. You are Jesus. Here is your pill. It must be that you don't even need to think. Otherwise, I believe it's not going to work. Yeah. And for diagnostic things, I think there are so many possibilities. I could speak hours about it. There are so many things that we could do. But I believe at the end of the day, only things where we as persons are not involved, are as little as possible involved. If we need to go and see a doctor, when was the last time you went to see a doctor?
Yeah,
for probably with your child or something like this, yeah, like me. If I am aching something, tomorrow it will go away. For my children, I immediately run to the doctor, but not for myself. It's not very intelligent, actually.
My mother didn't know what a Zumba instructor was when I grew up, but there are plenty of Zumba instructors. She probably didn't know what a barista was either, but there are baristas. So, you know, there will be new jobs, but of course, this time it will be more challenging, because more jobs will probably be affected, and it will not only be blue-collar jobs, it will be white-collar jobs. And I think we need to think about, sort of, from a societal point of view, implications for education. What kind of cognitive and non-cognitive skills do we need to sort of nurture in this new technological environment? Lifelong learning sounds like a cliche, but it's probably something we have to focus more on. And then, of course, you asked about sort of other implications. Probably, you know, we need to reform the pension system, of course.
And just sort of, I was just reading about how much time a GP in Sweden spends with their patient versus other countries, and I think we spent the least time with our patients, but we spend much more time with administration and so on. So I think, you know, you shouldn't be scared about IE being the most horrible thing. It's fantastic. It's about people spending time where they need perhaps to spend more time, and enabling things like administration or other areas, spending the time actually with qualified within science, spending the time right rather than doing a lot of things around there.
My question is to Frederick. You guys are doing some really weird stuff in the labs there. How much are you involved in the process of bringing these weird, very powerful techniques into the market and seeing what is actually happening with them? Are you involved? Do you want to be involved? And if so, how?
So our main focus is focusing on understanding human development. So which genes are controlling early human development? How do cell types how are they specified? So that's sort of our focus when it comes to embryo development. When it comes to the cell therapy branch, One big problem, if you take an embryonic stem cell and you differentiate it to the neuron or to a heart cell, is that when we transplant that into you, there's going to be an immune reaction because your immune system is going to recognize these cells as foreign. So there we're trying to use the gene editing systems to make sure that your immune system does not recognize this cell as a foreign cell. Instead, it thinks it's its own cell. So that's sort of an area that we're focusing a lot on and using this technology. Internationally, though, there are now efforts in trying to use this technology to go in and correct mutations in the early human embryo also. That's not allowed by Swedish law to do. We're not allowed to introduce a genetic correction or mutation in an embryo which is then inheritable. So we can't do, even if the technology was efficient and safe, it's not allowed to be done in Sweden. So we are not sort of venturing in that direction, of course.
Where is that allowed?
So in the US, depending on where you are and a little bit depending on how you interpret the law, you would be no, but in US it's quite special though, because they regulate this mainly through the funding. So that type of research would not be funded by the NIH. So that sort of shuts down most of the research. But if you can fund the research in other ways, you can do it.
It's legal.
And yeah, potentially could, probably. It hasn't been tested, but yeah.
But so this is actually an area where if we could sort of move forward in changing our regulation, that could give us a
because I mean, if you know that your family are carrying a mutation that will lead to severe disease in your child. And if we have the technology to go in and correct that mutation, why would you not want to do that? And we're already now, we're using something called pre-implantation genetic diagnosis, where if a couple have an inherited disease, you can go in and look at the embryo after fertilization before you transplant it into the mother and see, is this embryo carrying this mutation that will give rise to Huntington or cystic fibrosis, or is it not? And then pick the embryo that will not carry that gene. So we're already doing this sort of thing, and with this new gene technology we could probably go in and instead of just selecting, correcting mutations instead. So.
But how would we then, I mean, if we would allow that, which I totally agree that in these cases that makes total sense, but how would we avoid, for example, developing kids that have a super intelligence? Or
that would be awesome. I would love
yes, yeah. What is the problem with that?
What is the problem?
What if only rich countries can do it and the poor
I mean,
countries
it
in
would
Africa
start
don't have the
as many other things. It would start in rich countries, and as with everything which is good, it would find its way in every corner of this planet. Every parent of the world would do everything possible to have intelligent children. There's no question about it. Like mobile phone, you know, in Africa, in a rural part of Africa, a mobile phone is more important than a toilet there. It's just as simple as that. What you had before in the center of the village, there was a toilet and there was a church or something. Now it's a solar charge thing for people with a mobile phone. It's just like that. Awesome things might find their way. It's just like that. Why not? And I personally believe, you know, there are many parties, I don't want to say the names, these days that are advocates do not touch the human genome, do not hence human. I mean, you know, people say that the development of a person is usually, there are two main factors. The environment, which is like 50%, and the genetics, the other 50. We, in these Western countries, we already have the environment. You know, everybody has access to school, to hospitals, and to everything. The second thing which is missing is that every person is really have the same possibilities. Has a basal intelligence and a basal sport and this kind of thing. I believe the same parties, leftist parties, which are advocating today for against this genetic stuff and so on, are going to be the ones in order to have an equilibrium between all of us, that tomorrow are going to start pushing for it. The day it becomes safe, after your work is done, the day it becomes safe, they are going to advocate, okay, now let us do that. All this horrendous genetic, imagine having a child with a genetic defect. you don't want, nobody wants this. And then people will go, okay, if we can help the intelligence, why not? That would be awesome.
But I think there's a clear distinction, though, between enhancement and treating a disease. But that
course,
distinction,
of
of course,
course,
can be blurry. Sometimes treating a disease is also enhancing. So, but we're already making those types of distinction or sort of cut-offs already.